Hello guys, how are you? Welcome to the session here. Today I envision to demo this product called Analytic DB for Postgres, right? And let's call it ADB for PG. Now this is one of the core products offered on the Alibaba Cloud, which was designed and built on day one to handle highly concurrent complex queries, and the expectation is to return the results in a matter of seconds or minutes, depending on the amount of data, to serve the users and customers for handling online processing. So from user perspective, if there's a tons of users running a whole bunch of complex queries and everybody is expecting to see the results in a matter of seconds or minutes, that is your go-to product on the Alibaba Cloud. So to summarize, right, this is sort of like a high concurrently to handle high concurrency queries and hosted service on the cloud. I'm not going to dive into details about the product, the features, the product vision, and the product roadmap, which was actually covered in one of the previous videos. In this demonstration here, I am going to demonstrate, right, when you purchase, this one particular type of machine, what is the expected performance. I'm trying to do this demo because talking to some of our users and customers, people are asking, there's many different types of machines I can choose, different VMs, and I have different data sites, right? So you're saying this is fast, but how fast? What is a correct performance expectation? So to give you guys a sense or a feeling of performance, I'm going to go dive into performance. I'm going to dive into a benchmark test. And this benchmark test was designed by a very, very famous industry standard from tpc.org, right? So I'm going to demonstrate the TPCH Benchmark, which is a decision support benchmark. So there's 22 queries. All of those queries are very, very complex with a lot of select, a lot of joins, a lot of group by, very ad hoc queries, but business driven, right? To solve very complex problems. It is generally accepted by the industry that if your database, if your OLAP service can handle these queries well enough, then the OLAP service, it's good for day-to-day use in the business context. So we're going to use data points we collected from TPC and also the exact queries that are provided on the TPC website. So now let us start diving into the product demonstration. Now, as you can see, I have a list of products. I selected ADB for Postgres SQL. This is ADB for PG. Now, when I go in here, I see a couple of instances available. Let's use one of them. And this one, if you look at the specific resource configuration, this is ADB for PG version 4.3. And we have 16 cores, right? In terms of the compute nodes, we have 4 nodes, and each node has 16 cores, 128 gigabyte memory. So that's 2560 gigabyte SSD physical storage in total, right? And for each of the storage nodes, it has 4 cores, 32 gigabyte memory, and 320 gigabyte storage space. So that is the physical setup that we have. Let's dive into this type of machine and look at the performance. So I just recently created this instance, haven't used it at all. This is like a blank paper. I haven't done anything yet. The first step is to create a database account, right? So this allows me to operate. So let's call it maybe test schema, right? And then just give it a password. Give it a password and click OK. Now I got my account up and running. Right, let's refresh. Yeah, let's give it a moment for this account to be created correctly. All right. So let's see what else once we have this account. Oh, it's already active. So now let's try to log into this database. Let's copy the intranet connection string and go log into this database. right, so I'm gonna put in the URL and my username. Let's test the schema. My password. I want to remember the password and log on. This is to add it to the whitelist. Let's try again. All right, so now we are successfully logged into the operation console. As you can see, this is our test schema. And I'm gonna run some queries, right? First, I'm gonna do, let's say, create schema, demo schema, right? And run that. So at refresh, we should be able to see our demo schema. Now I'm gonna run a whole bunch of queries to demonstrate the performance of ADB for PG. So I've written these SQL queries, and those queries are all just copied from the TPC website. So first of all, the step number one is to create tables, right? To create internal tables within ADB. And step number two, we are going to create a whole bunch of external tables pointing to the data, the raw data stored on OSS. OSS is the object store service available and offered on Alibaba Cloud. And we're going to pull data from OSS into the internal ADB storage. This is to demonstrate performance, right? If you don't care performance, you can totally run these queries against your external table. You just suffer a little bit from a performance perspective, but it totally works. Now, in our scenario, we are next going to insert data from OSS into the ADB internal storage. And this is the most time-consuming process. Now, once we go through that process, we can run a whole bunch of queries, right? All these queries, query 02, query 01, 03, up to query 22. All these queries are provided and specified in the TPCH testing suite, right? This is for benchmarking purposes. All right, now let's get started. I'll just copy all these tables. So we create all the necessary tables. All right, copy all that. Let's open the new window. Okay, and let's put in all these. Let's run one of these queries to see if we are able to successfully create the table. Looks like we are able to. So let's just go ahead and run through all these queries to create tables. All right, I'm gonna execute. So some queries are going to take a little bit longer because as you can see, if I refresh, it's not just 8 tables. It's going to be over 170 tables because some of those large tables, like this one, the line item, it's going to have a lot of partitions, right? So we have all these tables and partitions ready at this point. Now we're ready to do step number 2, which supposed to be quicker. So I'm gonna create a bunch of external tables pointing to my raw data stored on the object store, OSS, right? I'm gonna create a bunch of these tables. I'll just run all these queries all together. Well, actually, maybe let's take a look. Starting from here, yeah, let's just run all these queries. All right, so now we've got the external tables and the internal tables. Next, we are going to import from the external table to the internal table. All right, so I'm gonna do that. Let's just copy all the queries and maybe run one by one. Okay. All right, so first, insert data into the nation table. All right, that looks pretty smooth. The region table, that's again only 5 rows, so that's pretty smooth. The line item, this one is going to take a little bit longer because we are effectively talking about 100 gigabyte, right? So the line item table, it's somewhere between 70 to 80 gigabyte with tons of rows. So we are ingesting all these rows from the object store into ADB internal storage. So let's give it a moment to execute the ingestion SQL. Okay, so looks like it wasn't too bad. Took this much time and we inserted this many rows. It's a lot of data for sure. Now let's try to execute the next ingestion. This is again a large table, right? For all kinds of orders. If you, as you can imagine, right? There's only this many nations, there's many regions, only this many customers, but there's a lot of orders, and there's a lot of line items for each order. So this is again going to take some time, but let's give it a few moments. All right, so that wasn't too bad neither. We inserted those many rows. And next, it is the customer table. All right, and the part table. Okay, the next one, the part supply table, and the last one is the supplier table. And the supplier table, which should be faster. Okay, so now we've got all the data we need, and we have dumped all these data into the internal storage. Let's move forward to try some of these queries, right? So this is the first query, right? As you can see, it's pretty complex. It's pretty complex, and let's see how long it takes to execute this query. Let's just double check, making sure the schema name and everything is correct. All right, let's give it a shot. Yeah, so this query is mainly operating on top of the line item table, which again, remember, it has around 70 to 80 gigabyte of data. So this is doing a very complex scan, getting data points, and do all kind of magic. And let's see how long this takes. While the query is being executed, let's do demo schema. Let's prepare the second query where a lot of joins are involved and order by and that kind of stuff, right? So let's do query number 2. Let's open a new window and put it down here. Yeah, so this is a query number 2. Let's go back and see. Wait, right? This is taking some time. All right, so we got the results back, and the total time used is 93 seconds. 93 seconds. So for this query, this is a very complex join where all these tables are involved. So let's give it a shot and see how the second query performs. All right, so this is pretty fast, only 5 seconds. And let's try another one. So for example, maybe like the fourth query. This is again a line item operation, and I'm gonna join with the order table and stuff. So let's try that one. New SQL window. Okay. Okay, so that was also very fast, 11 seconds. So maybe let's try something different. Let's try this one, query number 8. This is again a lot of joins, a lot of tables are involved. Let's see how this table performs. Okay, let's give it a shot. Yep, so as you can see, except for the very first query, due to the way the query was constructed, the rest of the queries, although like a lot of big tables are involved, a very complex join, a lot of group by, order by clause, we are able to get the results back in a matter of a few seconds to maybe 10 to 11 to up to like 20 seconds. So yeah, so this is, by doing this demonstration, I'm just hoping to give you guys a sense of performance, how fast ADB is, and you can make your own decision if this performance satisfy your needs. And remember that we're talking about 100 gigabyte of data. When you scale up, right? So for example, you want to handle a terabyte of data and table join, maybe like a multiple terabytes of the multiple tables. Each table has multiple terabytes. Then you necessarily have to just get more resources, get a bigger cluster to provide the necessary performance. All right, thank you so much.